Hello, class ninth. So we have been studying chapter number 9, force and laws of motion. Yes. So kids, in previous class we studied Newton's second law of motion, and we also studied about inertia and mass. Yes, the relation between inertia and mass, and apart from this we studied about momentum. Yes, momentum of a body. So these topic we studied in previous class, and we have already completed second law of motion and first law of motion. So first of all we will revise whatever we studied in previous class. So as you can see, Newton's second law of motion. Okay. So Newton's second law of motion. Yes. Because first of all we will study the second law of motion. Yes, first of law of motion we have already finished. Okay. So what is Newton's second law of motion? Okay. So second law of motion explain that the rate of change of momentum of an object is proportional to the applied force in direction of force. Yes, means the rate of change in momentum. What? Momentum which is changing with time, which will be directly proportional to the force. Yes, because you know that momentum generate when the force applied. So as much as the force applied, it will be proportional to the momentum generated momentum. So both will be directly proportional, means if one will increase, another will also increase. Okay, if force increase, momentum increase. If momentum increase, it means force is increasing. Okay, so the magnitude of force also increase. Okay, so the rate of change of momentum of an object is proportional to the applied force in the direction of movement. Is, and if we mathematically see, mathematically if we talk about the second law of motion, as you suppose that an object is moving, the mass of the object is m. Suppose the object is moving with u velocity. The u is the initial velocity of the object. When the force is applied on it due to acceleration, the when the force applied, its velocity increase in t time, and it's a due to acceleration, the velocity become v in t time by applying a force f. Then we can say, because according to second law of motion, rate of change of momentum, and we know that what is momentum. What is momentum? P is equal to mv. So here the initial momentum will become p1. Imagine that initial momentum is p1 and final momentum is p2, because we have given two velocity, u and v, initial velocity and final velocity. That's why here will be two momentum, initial momentum and final momentum. So initial momentum will become p1 is equal to mu. U is the initial velocity, and final momentum will become p2. P2 is equal to mv. V is the final velocity. Now, because in terms of change of momentum, we can say p2 minus p1. Okay, whenever we say the change is happening, change in momentum, change in velocity, when we talk that time, actually we subtract from the final minus initial. So here we will become p2 minus p1, means mv minus mu. M is common, so we will take m outside. It will become m is equal to, m into v minus u in the bracket. And because according to second law of motion, rate of change in momentum, whenever we talk about the rate, then we always divide by time, because momentum is happening with some time. Yes, means the velocity is changing in some time. Okay, so the time is t. So the rate of change of momentum will be equal to m into bracket v minus u divided by t. Yes, m into v minus u in the bracket and divided by t. Now, because according to this law, rate of change of momentum will be directly proportional to force. So we will write F. So F directly proportional to the m into v minus u upon t according to second law of motion. So if we remove the proportional sign, that time we will use always a constant. Yes, if we use equal sign, sign of equal and remove the proportional sign, that time we use a constant. So when we remove proportional sign, then we will write k. K is a constant here. Okay, k is a constant of proportionality whose value is 1. Okay, and now the formula will become F is equal to Km into V minus U in the bracket divided by T. Okay, where V minus U upon T is actually the value of acceleration. Yes, where V minus U divided by T is actually the value of acceleration. Okay, so in the place of V minus U divided by T, we will write A, because A is equal to V minus U upon T. Yes, it is the formula of acceleration. So the new formula will become F is equal to Kma, where K is a constant of proportionality, and F F is equal to, if we put K is equal to 1, then the formula will become F is equal to Ma, which is actually the formula of force. Yes. So if we find out the unit of uh, force, then we can say that SI unit of force will become Newton. The symbol is N, capital N, or one more unit is kilogram meter per second square. Okay. So this will be the mathematical formula of second law of motion, which state that the applied force is proportional to rate of change in momentum. Yes. Okay. We also know that what is momentum. Yes, we also know what is momentum. That the momentum of an object or the momentum of a body is the product of its mass and velocity. Yes, momentum of a body is the product of its mass and velocity. So it will become momentum is equal to mass and into velocity. P is equal to mv. Yes, if a body, suppose if a body is at rest, then its velocity will be 0, so its momentum is also 0. Okay, and SI unit of momentum is kilogram meter per second. Okay, so when the momentum increase, sorry, when the mass increase, momentum also increase, or when the velocity increase, that time also mass increase. Okay, so suppose a truck is moving with low speed, the velocity is low, but truck has more mass, so the momentum will increase. So if anything will come in front of it, it will crash it, so it can kill the people standing because of the heavy mass of the truck. Yes, I hope you understood. And we also studied in previous class about the inertia and mass. Yes, what is inertia? What is mass? What is inertia? A body. What is inertia? Inertia is the property of the motion. Yes, second law of motion. Sorry, first law of motion. And a body at rest, according to this, what is inertia? What is inertia? A body at rest, it remains at rest. Yes, or a body, if it is in motion, then it will continue to be in motion. This property of a body is called inertia. Yes, and how do we measure the inertia? Inertia is measured by the magnitude of force. Yes, magnitude of force means value of the force tells the actual inertia. If the force is increasing, then inertia is increasing. If inertia increase, then mass also increase, because inertia and mass are related to each other. Yes, inertia and mass are related to each other. Yes, I hope you understood. Now let's study the last law of motion, which is actually Newton's third law of motion. Let's move on the next point. Okay, Newton's third law of motion. Yes. So this is the most easiest law of motion. Yes. This is the most easiest law of motion. Yes. And it's very easy. Yeah. It's just like a piece of cake. Okay. So Newton's third law of motion states that to every action there is an equal and opposite reaction. Yes, to every action there is always equal and opposite reaction, and they act on two different bodies. Yes, they act on two different bodies. Yes. Okay. Every action has equal and opposite reaction. For example, suppose your best friend will slap you. No, no. Let's take in a different way. Suppose your enemy. Okay. Suppose your enemy slap you. Okay. Imagine you have a danger enemy and he comes to you and he slap at both of your cheeks. Yes, on your both cheeks. He slaps. Then what will you do? What's your reaction? Because this is action. He slapped to you. You will also slap him again. Why? Because he slapped you without reason. So you will slap. So what is this? Action and reaction. Yes. So to every action there is equal and opposite reaction. Yes. So when your enemy slap you, this is action. And when you will again slap, this is reaction. So to every action there is always equal and opposite reaction. Okay. Uh, to prove that action and reaction are equal and opposite, let's do an activity. As you can see on your screen, yes, as you can see on your screen, take two spring, take two spring balance. Okay, spring balance. There are spring balance also available in our lab. Okay, take two spring balance, give them name one A and B. Okay, connect with each other. Okay, they are connected together, and then fix the spring balance. Take two spring balance, take two spring balance A and B, and then connect them together. Now fix spring balance B to a rigid support. Yes, you will fix the spring balance B to rigid support, or you can fix spring balance A. Anyone you will fix to a rigid support. Okay, imagine that you fixed the B spring balance to rigid support. Okay. Okay, I hope you understood. So you will fix it, and kids, what is the work of spring balance? Can you tell me what is the function of spring balance? Well, spring balance tell you actually the force acting on a body in Newton. Yes. Okay. When a force is applied by pulling the free end of the spring balance. Yes. When a force is applied by pulling the free end of the spring balance. Okay. A. Suppose now you pull the spring balance A. Try to pull the spring balance A by applying a force. Okay. Which is actually the free end. So you will pull the free end by applying the force on a spring balance A. Then what will happen? When you will try to pull A spring balance, that time B spring balance will also extend. That time, suppose my hand, one hand is left hand is B, right hand is A. When you will pull A spring balance, that time B also extend. Both will stretch. Okay. So both the spring balance shows the same reading. Yes, both the spring balance will show the same reading. Why? Because they are connected. You are applying the force on A, which is actually action, but actually something reaction is also happening. Yes. So both the spring will show you the same reading. This shows that the force exerted by spring balance A on B is equal to opposite in direction to the force exerted by spring. Yes. So it shows that that when you pull spring balance A, yes, that time you are applying force, that time the force is applying by A spring balance, yes. So that the force exerted by applied by A spring balance, which is actually applying the force on B spring balance, yes, which will be equal but opposite in direction, yes. And according to Newton's third law of motion, to every action there is equal and opposite reaction. So you are pulling A spring balance, which is action, but the effect is also on B, which is actually a reaction, yes. So but the value is same, the action value is same, okay, value will be same, yes, value will be same. The spring of A spring balance will go in right direction, and the spring of B spring balance will go in left direction. The spring of A spring balance will go in right direction, the spring of B spring balance will go in left direction. So it is showing the opposite direction, but the value will be same. But the value will be same. As you can see, the value will become, suppose their value, if spring balance A is showing you 100 Newton, the value of force it is showing 100 Newton, then B spring balance will also show you 100 Newton, okay. So the force exerted by spring balance A, the force exerted by spring balance A on B is balanced B on A. And the force exerted by spring balance A on B is action, and the force exerted by spring balance B on A is reaction. Yes. So the force exerted by spring balance A on B is action, and the force that exerted by the spring balance B on A is reaction. Yes. Because when you are trying to pull spring balance A, that time force is also acting on the B, because when you will pull A, that time pull spring balance will B will also pull, yes, but it is on the B spring balance is on left direction, it will pull. So B spring balance is also trying to pull the spring balance A, but both are in opposite direction going according to Newton's law. So to every action there is equal and opposite reaction. Yes, to every action there is equal and opposite reaction. Okay kids, let's understand it with some examples. Let's move on the next point. Okay kids, let's see two examples related to Newton's third law of motion. So I remember kids, what is Newton's third law of motion? To every action there is equal and opposite reaction. Yes, to every action there is equal and opposite reaction. For example, as you can see the picture of gun. Yes, can you see the picture of gun? So when you will shoot using the gun, suppose you have enemy. Suppose you have enemy. You take away the gun to shoot your enemy. Yes, at night you went to shoot your enemy, and as you will shoot, when you will use the gun, that time what will happen? The bullet will go forward. Yes, when you will fire from gun, when you will fire from gun on your enemy, then the bullet will go forward. Yes. So, and that time you might have noticed that the gun will come backward. So what is happening? The bullet is going forward, it is action, and the gun is coming back, it is reaction. So when a bullet is fired from gun, that time what happens? It exert a forward force. Yes, when you shoot from gun, that time the bullet goes forward. Why? Because the gun is applying a force. The gun is applying the force on the bullet. The gun is applying a force on the bullet, which is actually action. Okay. At the same time, bullet also apply the force on uh, gun in backward side. So it is reaction, and both are in opposite direction. Yes. So when a bullet is fired from gun, it exerts a forward force on the bullet, and the bullet exerts an equal and opposite force on the gun, which is actually a reaction, and the gun recoils. Yes, and the gun recoils. Recoils means it goes back. Okay, the gun recoils means it goes back. So this is the example of Newton's third law of motion. Yes, every action has equal and opposite reaction. Okay, let's see one more example. Yes, as you can see in the picture, this is the dramatic scene of movie Pirates of Caribbean. Okay, this is the dramatic scene of Pirates of Caribbean movie. Yes, the famous actor Johnny Depp is coming from the sea to the land. Yes, you can imagine. Yes, if you have seen it. So whenever, if you have ever went if you have ever traveled through the boat ship, if you ever traveled through the boat for the enjoyment purpose, if you ever gone to somewhere like in park, yes, you might have seen. If you will go to Ajmer, yes, there is also you can see you can sit there in the boat. Yes, there is a big park where you can go and enjoy. So you might have seen that when a sailor jump out of the boat, then what happens? When he will put his feet on the land, when he will put one feet, when he will put one foot, when the sailor put one foot on the land and another foot is in the boat, is at the same time, when the sailor will put the second foot also from, when the sailor will put the second foot also from the boat to the land, then what will happen? He is trying to go on the land. Yes, he is trying to move forward. He is trying to move forward. That's why he put one foot on the land. So he is trying to push his body, and at the same time he is putting his one foot from the boat, another leg from the boat to the land. That time what is happening? What is actually happening? When a sailor jump out of a boat, he exert a backward force of the boat. Yes, he exerts a backward force of the boat. Yes, he exerts a backward force of the boat, which is actually action. Yes, when he try to jump on the land or when he try to come on the land, that time the sailor will try to come on the land, then he exert a force, a backward force he will exert. Yes, because of his feet, the boat will go back. Because of his feet, the boat will go back, which is actually action. At the same time, boat will also try to apply a force. So when the boat exert at the same time the equal force on the sailor, so he will be able to come on the land. So which is actually a opposite force which is applying by boat. So first of all, sailor apply the force on the boat, so little bit boat will go backward, which is actually action, and at the same time boat will also apply the force on the sailor, and that's why he will go forward, so which is actually a reaction. So it is action and reaction. Yes, so I hope you understood that To every action there is equal and opposite reaction. Yes, to every action there is equal and opposite reaction. Yes. So I hope you understood Newton's third law of motion. To every action there is equal and opposite reaction, and they act on the two different bodies. Okay. Now let's move on the next point. Okay, it's time to ask some question from you. Question number one. Write the following formula. Yes, you will write the formula. Momentum. What is the formula of momentum? Yes, kids. Momentum is denoted by P. What is the formula of momentum? Yes, P is equal to mv. Yes, and its unit is kilogram meter per second. Force. What is the formula of force? Yes, the formula of force is m into a. Yes, force is mass into acceleration. Okay, and if we talk about the unit, its unit is Newton or kilogram meter per second square. Yes, both are unit. Now question number two. Question number two is explain Newton's third law of motion. Yes, explain Newton's third law of motion. Okay, so according to Newton's third law of motion, to every action there is an equal and opposite reaction. To every action there is equal and opposite reaction, and they act on two different bodies. Yes, one body will act on another body will act on the first body. Yes, first body will act on second body will act on the first body. So both are acting on different body. Example, when a bullet is fired from a gun, it exerts a forward force on the bullet, and the bullet exerts an equal and opposite force on the gun, which is actually reaction, and the gun recoils. Yes. One more example, when a sailor jump out of a boat, he exert a backward force, which is on backward force of the boat. Yes, the sailor exert a backward force of the boat. Yes, sailor apply the backward force. Yes, which is actually action, and the boat exert an equal and opposite force on the sailor, which is actually reaction. So the sailor jump forward. Yes, it's very easy. Question number three. When a rocket is fired, why does it go upward? Yes, I will not tell the answer of this question in next class. I will tell you the answer of the question. When a rocket is fired, why does it go upward? Okay, you will find the answer. Try to find. Otherwise, I will tell the answer in next class. Okay, don't worry. Now we will meet in next class. Till then, bye bye.